Hello class, Mr. Parsons here. I just want to take a few minutes to talk to you about scatter plots and association. So we use scatter plots to help us determine if there's association between two variables, and that's called a bivariate data. We have two variables. Scatter plots helps us to look at numeric data between those two variables. And so we're looking at this example here. If you notice, this is an example of what a scatter plot looks like. It says Zara surveyed shoppers at a mall to see how many items they purchased and the amount of money they spent at a mall. She used the data to create a scatter plot. How many shoppers did Zara complete the survey? So in order to determine how many shoppers, so each point represents a shopper. So if you count all of these points, you get 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. There are 16 shoppers in the survey. All right. It says, does the number of items purchased seem to have an effect on the amount of money a shopper spent? So kind of look at the plots, right? Think about it. The more money you spend in a store, right, generally the more items you get, for the most part. So it does look like there's some type of an association here. As the amount of money increase, the total spent increase, the number of items increase as well. So that looks like there is association between those two variables. And so when we look at that association, we got positive association, negative association, and no association. So think about your plots kind of clustered together to form like a line, or sort of like a line moving in one direction. All right. So if you look at the positive association, you know, as one variable increases, the other variable increases. So like as my X increase, my Y increase. So look at your dots. They're kind of clustered together, going in one direction, like going upwards, going in a positive direction. That represents a positive association. All right. A negative association is in reverse. As one variable decreases, the other variable also decreases. All right. So as my X, as one variable increases, the other variable decreases. I'm sorry. So as X increases, Y decreases. So you see your points are clustered together, but then they're going down. Think about a linear equation. Think about a negative slope. It's kind of similar to that, but it's just with scatter plots instead of with a line. And then no association is one variable doesn't have an effect on the other variable. So for example, your favorite color does not have an effect on the temperature outside. All right, so that's an example of no association. So basically it's just random plots or random points plotted on a graph that doesn't form any type of association. All right. So then let's think about this using real world situations. Let's think about their type of association. The number of shoes a person owns and the number of states they visit. Does the number of shoes a person owns affect or have any association with the number of states a person visits? No, it don't. So therefore it will be no association. All right. The size in ounces of a steak and the cost of a steak. So think about it. How big a steak is, think about a restaurant. Does how big your steak affect how much you pay for the steak? And it does. There's going to be association. So the bigger the steak, the more money you spend, that's going to be a positive association. All right. And then look at number 3, the number of days since watering the plant and the moisture level of a soil. So basically what it's saying is when you water your plant, the soil is real moist. But then as as each day increases, the moisture level decreases. So it is an association, but it's going to be a negative association. All right. Now let's look at strength. All right. Strong association, negative association. So when you're looking at strength, you're looking at how clustered they are, how close the points are together versus how spread out they are. The closer the points are together, the stronger the association. The more spread out the points are, the weaker the association. So you see these points right here, they're closer together. This is more of a strong association. These are more spread out, so these are more of a weak association. When you think about linear versus nonlinear, think about linear equations and linear functions that we've been working with. So if our scatter plots kind of form a line, when they cluster together and they trying to form a line, all right, it's going to be a linear function. If it doesn't form a line, if it forms like a curve or anything like that, then it's going to be nonlinear. So if you look at this right here, this is going to be a linear function because it forms it's trying to form a line. You can see there's some type of association. Generally, if there's association, all right, there's going to be a linear function. All right, let's look at this right here. All right, notice there's no line. All right, so it's going to be a nonlinear function right here. All right, and let's look at these scatter plots to determine our association. So look at A, B, C, and D. It says which scatter plot shows linear association. So which scatter plot kind of forms a line as they're clustered together or form in the same direction with no curve. So if you look, A, that's kind of forming like a curve right there. B, it's more of a line. C is kind of forming more of in the same direction like a line. D is kind of forming like a curve. So the scatter plots to show a linear association, that's going to be B and C. Which scatter plot show nonlinear? All right, so if B and C shows linear, then nonlinear would be A and D. Which scatter plot shows the weakest association? Meaning, which scatter plot is spread out the most? That will be C. All right, this is a weak association. Which scatter plot shows the strongest association? Which scatter plot are closest together? And that will be scatter plot A. All right, let's take a look at these and try to see if we can't match which is which. So we got positive and linear, positive and nonlinear, negative and linear, negative and nonlinear, and no association. So if I had to look, right, this right here, it doesn't form a direction whatsoever. So this looks like this might be no association. We're going to double check. All right. If we see this here, look, as X increases, Y increases. All right, that's positive, and it's kind of like trying to form a line, so it's going to be a linear. So this will be positive and linear. All right, this is as X increases, Y decreases. So this is going to be a negative association, and it's going to be linear. So this is no association, positive and linear, negative and linear. Now, let's look at these scenarios to see which will represent what. The temperature outside and the total gallon of gas showed at the gas station. Well, does the temperature have an effect of the amount of gas? All right, you want to think about that. And if it don't, that's going to be a no association. All right. Let's look at the altitude of a hiker and the total oxygen level in the air. So the higher the altitude, the less oxygen is in the air. All right, so as X increases, Y decreases, that might be negative and linear. And then the size of a home and the cost of a monthly utility. Yeah, the more people in the house, the higher the bill is going to be. All right, so that's going to be positive and linear. So this temperature represents no association because temperature has no effect on the gallon sold. The altitude and the total oxygen in the air, negative and linear. And then the size of a home and the cost of monthly utilities, that's going to be positive and linear. All right. So when we looked at with scatter plots and associations, scatter plots helps us to understand the relationship between two variables, which is about bivariate data. All right. You want to look at, first of all, association. All right. Meaning if they form as X increases, Y increases with your scatter plots, that's going to be positive. As X increases, Y decreases with your scatter plots, that's going to be a negative association. But if you just got random plots on the graph, that's no association. Then you want to talk about your strength. All right, if they're more clustered together, it's going to be strong. If it's more spread out, it's going to be weak. And then also, if it forms like a line, if the scatter plot's kind of looking like it's forming a line, all right, that's going to be linear. If it's looking like it forms like a curve or something like that, then it's going to be nonlinear. So this is what we're looking at with scatter plots and association, and I hope this helps with our understanding of scatter plots and association.